Welcome back. This lesson is on algebraic proofs, and your objective is to be able to justify each step when completing a problem. We're going to get right into it here. This first example is all filled out for you. I'm just going to talk you through it, and we can kind of see what I mean by proving our steps. So we already know how to solve equations, and we've talked about what steps to take, and we've also talked about properties of equality. We're going to put those two topics together and prove how we solve our equations. When we start with an algebraic proof, we're always given something. So in this case, we are given 9 minus 4x equals negative 19, and it says right here, given. So that's our statements. This is a two-column proof. We've got our statements and our reasons. So we're always going to have the same amount of statements as we do reasons. And our first one will always be given. We have to know what we're starting with, so we always will have a given step. Now we're basically going to go through and solve the problem. As we solve the problem on the left, we're going to say what we are doing or why we can do that on the right. This is not a because I said so situation. This is more of a justify, like why you're doing what you're doing. So if you were to get in trouble and you could justify it to me, or if you're doing something and I'm like, what are you doing? And you could justify it, then you're good to go. Same goes with your math work. If you can show me or tell me, we're good. So right here, I'm just going to go ahead and kind of complete the problems in between the steps so you can see what was happening. We're completing the order of operations backwards. We know how to solve equations. So what they did was subtracted 9 from each side. So for the reason down here, and this is what we're left with. We're left with negative 4x minus 28. The reason, this is trippy, I'm starting right away showing you something weird. I didn't mean to do that. Is the addition property of equality. Now, what is actually happening here is we're subtracting. When you take your OST or your state test, even if you subtract, and you would think it would be the subtraction property of equality, they may not give you that option. So what they want is that instead of subtracting, you can add. You can add a negative. So subtracting, it's the same as plus a negative, right? We're still taking away, we're still getting smaller. So they may not give you the option of subtraction. When they don't give you the option of subtraction, you choose addition. When they don't give you the option of division, you use multiplication. But division, they'll give you the option usually. It's just subtracting that they don't like. All right, so we're adding a negative or we're subtracting. So that's the addition property of equality. And now we have negative 4x equals negative 28. We're going to divide both sides by negative 4 to get x equals 7. The division property of equality allows us to divide both sides of the equation. The second proof here, we are given the statements, and that's the working out of the problem, but we're not given the reasons. So we're going to work this one out and see if we can remember or come up with our reasons. When you are assessed on this, when you have your assignment in Google Classroom, I'm going to give you the reasons and you can choose them. But for our purposes of learning, I'm not going to have like a bank or anything right here. We're just going to go through them and talk about what it would be. As you can see, our given, it tells us what's given. It's x minus 3 over 6 equals negative 2. That's our first statement, and the reason is given. We have to start with what we're given. Do you like my lightsaber? I think it's kind of cool. Okay, I'm getting sidetracked. Now, we need to see how we can get from here to here, from 1 to 2. So what did they do in order to move from x minus 3 over 6 equals negative 2 to x minus 3 equals negative 12. So what they did here, and if we just remember how to solve equations and follow the order of operations, they multiplied both sides by 6. So that our reason is the multiplication property of equality. We can always abbreviate. Mathematicians don't like to write stuff out, right? So that's the multiplication property of equality. Now we have to move this 3 away. And we did that by adding 3 to both sides of our equation. Remember, both sides. And we get x equals negative 9, which is what we were to prove. And we did that by the addition property of equality. Kind of see what we're doing here? You just solve it, and then you say how you solved it. Prove it. Okay, I put it in the middle this time, so our code word can be meow, because that's Grumpy Cat. I heard he passed away. It's like the saddest thing ever, but at least we have him immortalized in memes for me to make you roll your eyes at for the rest of your life, or at least the rest of the semester. We have an even more blank proof here, 2-column proof. So what we are given is the problem. I'm just going to copy it. Now we have to actually solve the problem. Now this would be a really good one to pause and try on your own. And then even step by step come back and play it and pause it and play it. Because this is the most blank one that we're going to see here. And you'll get an idea if you are starting to grasp it. So if you paused it and you're back, or if you didn't, either way, we're going to do our first step to solve this, which is to distribute. And that's what we did, we distribute. That is a reason. Now we need to do the order of operations backwards. So to start to get x alone, we're going to add 3 to both sides. We added to both sides, so it's the addition property of equality. And our last step to prove that x equals negative 2, and just so it's a little trick, I guess, x equals negative 2 is what we're trying to prove. That should be our last statement, right? We're ending there. Once you prove it, you're good. So that should be what we end on always. And that looks like what we are actually going to end up with here if we keep going. We're going to divide both sides by negative 12. And we get x equals negative 2. And we did that with the division property of equality. All right. We've got 2 more examples. It's a little bit longer of a video. Again, so I'm going to kind of go a little faster through these, but luckily you can pause it, you can rewind it, you can do whatever you need to. You can mute me, but I don't recommend it. 28 minus 6x equals 2x minus 84. That's what we're starting with. And we know we want to end with or prove that x equals 14. If we don't get there, we did something wrong. So the very first thing that we want to do is get all of our x's on one side. And I like to move the smaller one. Are you getting tired of hearing me say the same things yet? So we got 28 equals 8x minus 84. And we added, so we're using the addition property of equality. Now we need to move this 84, and the opposite of subtraction is again addition. We can do the same step twice. You can have the same reason 2 times. No big deal. You can hear my husband rustling around in there if you're wondering. I don't live alone. He just must be hungry. Anyway, we've got 112 equals 8x. And we use the addition property of equality again. And when we divide both sides by 8, we do get 14. And we use the division property of equality for that last step. But see, we're just kind of solving. So actually, these little steps right here that I have in between, I'm just showing you. If you want to do them, you can. They're not necessary. All you have to do is put in the actual statements. You don't need to include each reason. But I like to, or not each reason, each little itty bitty step. I like to when I'm teaching it so you can see exactly what's happening, but in your 2-column proof that does to go there. One last one. This one's a monster. We know that our first reason is given. Always. And what are we given? We're given -7 times the quantity x minus 4 plus 2x, I'm running out of room, I write too big, equals -2 times the quantity x minus 5. Barely. Okay. And we want to prove our last step should be x equals 6, right? Okay, so the first thing that I see that we need to do is to distribute. So we need to distribute the -7. And we actually have another thing to distribute here too. So we're going to do those both at one time. We end up with and I just distributed that quickly. If you want to stop and see and double check me, you can, but we distributed, and that is our reason. Now there's a new step that we haven't done before, and that is to simplify. Now we see that we have to combine like terms here. We have a -7x and a 2x on the same side of the equal sign. Because they're on the same side of the equal sign, we can take care of them both. We can put them together in one step. So we're combining like terms. The reason that we call that is simplify. You're just making it more simple for yourself. You're just rewriting it. And that's what we are left with once we simplify. Now we need to get all our x's on one side. You know I like to move my smaller x. Which means we have 28 equals 3x plus 10. We did that using the addition property of equality. Now we need to move that 10, so we're going to subtract 10 from both sides. $18 equals 3x. Now that's a subtraction property of equality, but remember, if they don't give you that option, it could also be addition if we did the plus and negative. Just a little reminder there, but we do have the option of subtraction here. And now I need to divide both sides by 3. And we end up with x equals 6. And that's what we wanted to end up with. And we got that by the division property of equality. That's it for proofs. You just need to take what you're doing and tell me why you're doing it by saying what property. If you have any questions, you know how to get a hold of me. Have a great rest of your day.